Okay, welcome. This is 3.1. So now we get into simple interest formula and simple interest theorem, how to calculate all of that. So we first start off with some definitions right there. Principal is the amount of money borrowed or invested. Interest, that's the fee charged for the money borrowed or invested. And then the interest rate, percentage computed on the amount borrowed or invested over a given period of time. Okay, and then conversions. So these are important for the conversions. Parts of a year. So 1 year is 4 quarters, 12 months, 52 weeks, and we say 360 days. We call this the banker year, which you'll see it mentioned in the homework. So it's a banker's year, 360. Okay, so the first formula only calculates interest. It's called the simple interest formula. And it's given by I equals PRT, where I is the interest, P is the principal or beginning amount, R is the rate, and T is always in years. Time is always in years. Okay, so those are the components. So our first exercise is we are going to practice rearranging the simple interest formula to solve for P, to solve for R, and to solve for T. It is very important to know how to rearrange a formula to solve for a specific variable. Okay, so first thing we'll say is solve for P. Solve for P. So given I equals PRT, we want to solve for P. So in order to get P by itself, you divide by RT, you divide by RT. This means that I over RT is equal to P. So there you go. Save that for later. So that is an equation, simple interest in terms of P. Now, let's say that we want to solve for R. Let's go for that. Solve for R. Again, I equals PRT, and we want to solve for R. So this means you'll just divide by PT, which means I over PT is equal to R. Okay, save that for later. You never know when you'll need it. And then last one is solve for T. Solve for T. I equals PRT, and all you have to do is divide by PR, divide by PR, and I over PR is equal to T. Which means that these are three, this is the same formula, but rearranged 3 different times. So if you solve for P, that means you're looking for the beginning amount. If you solve for R, that means you're looking for the rate. And if you solve for T, this means you're looking for time, the amount of years. Okay, so that is just practice on how to rearrange a formula, which can come in handy. Okay. So next, is, forgot control to get on here too. That's right, doing this a little different today. Okay, so number 2 is giving us the components for simple interest. So P equals 700, R equals 8%, and T equals 6. It wants us to solve for I. Okay, so they're giving us everything we need. So all I have to do is say I equals the beginning amount of 700 times the interest rate of 0.08. Remember, we always convert to decimal. Times time, the amount of years, which is 6. Okay, let's type that in. $700 at 8% interest for 6 years will get $336 of interest. Now, maybe that's good interest or maybe it's bad interest. Majority of the time, it's bad interest, right? You took out a $700 loan for 6 years, it gets $336 interest on it. So you don't pay back the $700, you pay back $1,000.36. $1,000.36 back. Yeah. So that's how we do that. And we'll do another example, which is right below. So using the same formula, find the interest on the following loan, $1,200 at 3.5% for 9 months. Okay. So it's giving us the components, but this time, let's go ahead and label them. So the beginning, the principal amount, P, was 1,200. The rate is 3.5%, but we always convert to decimal, 0.035. And time is given as 9 months. Well, from the above, time must always be in years. So you must convert months to years. So we will do 9 months over, how many months are in the year? 12 months. 12 months. And 9 over 12, we get 0.75. So this becomes 0.75 years. So that's what we want to use. Time must always be in years. Okay, well, we have all the components. So now let's plug them into our simple interest formula, right? We have everything. Plug it into I equals 1,200 times 0.035 times 0.075. And I equals 1,200 times 0.035 times 0.075, not 0.75, 75. Woo. See, catch those mistakes now. 75 close, which means that this needs to change to 0.75. There we go. Hit enter and borrowed $1,200 at 3.5% interest rate for 9 months, and it'll gain interest of $31.50. Okay, that is simple interest. The next formula is simple interest theorem. I think we saw this in, what was it, exponentials, I believe, in 2.5. So it didn't have a name on it just yet, but this is the simple interest theorem. And the amount owed if you borrowed money and paid it back with simple interest is computed by this formula. Amount equals principal plus simple interest. So something we've learned today, right? A equals P plus I. Well, we know that I is PRT. So A equals P plus I turns into A equals P plus PRT. And to simplify this formula, we have a greatest common factor of P. So all they do is factor it out and leaves us with this new formula of A equals P times 1 plus RT. Okay, so for simple interest theorem formula, A is the final amount or future value. P is the principal or the beginning amount. R is the rate, and time is always in years. Okay, so we want to do the same exercise in practicing rearranging this formula for specific variables. So we want to solve the simple interest theorem formula for P, R, and T. So let's get started with that. First thing we're going to do is say solve for P. So solve for P. Okay. So A equals P times 1 plus RT. We want to get P all by its lonesome. So all we have to do is divide by 1 plus RT. Divide by 1 plus RT. Which means that we get A over 1 plus RT equal to P. Save that. Okay, then next, let's go ahead and solve for R, which means we'll start off with A equals P times 1 plus RT. Our job is to solve for R. We need to get that R out of the parentheses. So the very first thing to do is get rid of this P. We will divide by P, divide by P. I get A over P equals 1 plus RT. Okay? Remember, we still need to get this R all by itself. So the next thing to do is move over this 1. Subtract that 1 to the left side, which means I'll get A over P, somewhat of a P, right? I get A over P minus 1 equal to RT. Okay, so before moving on, I want to combine these terms, which means I'm going to get a common denominator. So I'll move to the next step here. I'll write smaller, of course. So this becomes A over P minus 1 over 1 equal to RT. So now if I want a common denominator, well, I'm looking at a common denominator between P and 1. The common denominator is just P. So I'm going to multiply this 1 over 1 by P over P. This will give me A over P minus P over P equal to RT. We're almost there. Then this becomes, since they have the same denominator, this becomes A minus P over P equal to RT. All right, almost there. Now our job is to solve for R, so we will divide by T. So I'm going to show you a nice little shortcut, but let me show you the hard way first, right? This means to solve for R, I divide by T, I divide by T, which means I'd have to put T over 1 and multiply by the reciprocal. Well, it's actually better to, instead of divide by T, multiply both sides by 1 over T. It's the same thing as if you were to divide T. We're just making the process easier. So this becomes A minus P over PT or TP, whichever you like, equal to R. There it is. There's the formula for R. And now, let's solve for T. And when we solve for T, I'm going to start out by using this formula. Oop, hang on. There we go. Had to wait for that to catch up. Okay, so this is where we're going to start at. So this is coming right here. A minus P over P equals RT. Okay, so that's where we're starting. Okay, and I'll get rid of that. And the reason we start there is because now it is easy to solve for T if we divide by R. I can divide by R, I can divide by R. And again, just like the last one, dividing by R, I'd have to put it over by 1 and then multiply by the reciprocal. So that's the hard way. The easy way is don't divide by R. Multiply both sides by 1 over R. 1 over R. And if we do that, I end up with A minus P over RP or PR, whichever you like, equal to T. There you go. Okay, excellent. Let's separate them. All right, now we have just rearranged the simple interest theorem for P, R, and T. That's it. Remember those formulas. Now we can use them. We will practice using them in the problems below. So let's start with A. It's giving us everything we need. P equals 3,000. Rate is 4.5% and time is 30 days. Solve for A. That means we're going to use the original simple interest theorem above. So it's giving us everything we need. So let's plug it in. So we're going to get A equals the beginning amount of 3,000 times 1 plus the rate, and I'm going to put this in parentheses now because it's RT, of 0.045 times, now here's where we have to convert. Time must always be in years. So this means T is going to be 30 over 360. Because for these examples, we are using 360. Let me show you what I just did there. So for time, it always must be in years. So time is 30 days. There are 360 days in our financial year. And if you divide those, 30 over 360, we get 0.08333. So honestly, leave these as fractions. Trust me, leave them as fractions. So 1/12. So 1/12 of a year. Or I'm just going to leave it as 30 over 360, but that's what I'm showing you there, okay? So that's how we convert. Okay. Now, I'm going to type everything in my calculator just as you see it there. So I have my calculator up, and you get 3,000 parentheses 1 plus parentheses 0.045 parentheses. I can use my fraction button here, or you don't have to. You just do 30 over 360. Close that, hit enter. We get $3,011.25. There it is. That's how it works. Okay. So you can type in 30 over 360 or 1/12. You'll get the same answer. Okay. Let's try the next one. P equals 19,000. R equals blank. So that means we're solving for R. T is 39 weeks. And A is 22,135. So this means that for this example, we're going to solve for R. Well, it's perfect. We already created an equation for R above. So this is the formula we are going to use right there. So let's set that up. It's giving us everything we need. So I can change colors, sure. So R is equal to, and we're using the formula above, the value of A, 22,135. Sure, I'll put parentheses for everything I plug in, minus the printable amount of 19,000 all over the printable amount of 19,000 times T. All right, so T is 39 weeks. If we scroll back up to my conversions up here, there are 52 weeks in a year, right? 52 weeks in a year. Okay. So for my conversion, I'm going to write 19,000 times 39 over 52. And this is exactly how I'm going to type it in my calculator. So here we go. Fraction button. 22,135 minus 19,000 over parentheses 19,000 times 39 over 52. Fraction button or not. Enter. I get 1150, but we want a rate. So I'm going to hit the double arrows, and there's our rate. That looks like a credit card rate. You get 0.22, which means we'll take our decimals, convert them to percents. So that means the rate on this loan is 22%. There we go. And I'll write it for you again, the conversion over here. So for T 39 weeks, since time is 39 weeks, there are approximately 52 weeks in the year. I leave it as that, or does 39 over 52, does that play nice? You get 0.75. So yes, you can get 0.75 or 3/4. So this one's fine to use decimal number because it's only 2 decimal numbers. For the very first example, if I scroll up, when I did 30 over 360, looking at the calculator on the left side, I got 0.083333 repeating. So when you get a decimal number like that, a really long decimal number or a decimal number that repeats, it is best to use fraction form. Like I said, just trust me on that. If you start cutting out decimals, let's say that you didn't type in 1/12, let's say you typed in 0.08, you're going to get a totally different answer off by a couple dollars, maybe even more than a couple dollars. So the more decimals you cut out, the more your answer changes. So try to keep it fraction form only if your decimal is ugly like that, okay? So that's a warning. All right, there we go. Okay, still going. All right, these are fun, right? All right. Okay, here, solve for T. So A equals 693, P equals 550, R equals 13%. We're looking for T. So we're going to use the formula that we have right there above. A minus P over PR. Okay. So solving for T, you get A, which is 693, minus P, which is 550, over P, the original amount, 550, times the rate of 0.13. 0.13. Okay, remember, always convert your percentages to decimal. And now, that's all we type in the calculator. Fraction button, 693 minus 550 over parentheses 550 times 0.13. We get 2. 2 what? 2 years. All right. Perfect. Okay, there it is. And now the next one is A is 9,000, R is 13%, T is 13 weeks, and P, we're looking for P. So again, we're going to use the formulas we rearranged above, the one that says P. So we're given all the information. So P equals A, 9,000 over 1 plus the rate, 0.13, times time. And time is 13 weeks, so that's going to be like B. We're going to put 13 over 52. Let's type that in. So fraction button, 9,000 over 1 plus parentheses 0.13 times 13 divide 52. Boom. To 2 decimal places, 8716.71. There it is. Okay. So let's say you didn't have the calculator with the fraction button and you had to type these in. So with the last example for D, I would do 9,000 divide parentheses 1 plus parentheses 0.13 times 13 divide 52. Close that, close it again, boom, 8716. Same thing with time. Let's see, like for C, like B and C, this is how you would type it in. I would do parentheses. I'll just do C, 693 minus 550 over parentheses 550 times 0.13. There it is, 2. So stuff like that. Okay, perfect. Let's move on. Now we get to actual word problems. Okay. All right. So in all problems involving days, a 360-day year is assumed. Express the rate as a percentage correct to the thousandth place. 3 decimal places. Round dollar amounts to the nearest cent. Okay, cool. So rates as 3 decimal places. So a loan of $10,000 was repaid at the end of 6 months. What size repayment check, principal and interest, was written if a 6.5% annual rate of interest was charged? So we need to know what formula to use. Is this just simple interest or is this simple interest theorem? Well, this one wants to know what check was rewritten to pay back this $10,000 loan. So we would use simple interest theorem. So this means that we would use A equals P times 1 plus RT. Okay. So label everything that we're given. We took out a loan of $10,000, so that's P. And then we repaid it at the end of 6 months. So time is 6 months. But time must always be in years. So you would put 6 months over 12 months, which is just 0.5 years. And that decimal number is fine because it doesn't run on repeatedly, or it's not one big ugly decimal number. Okay. Okay. And then the rate given is 6.5%. So 0.065. All right. It looks like we have everything we need. Plug it into the formula. A equals 10,000 times 1 plus the rate 0.065 times the time, close, close. Type this in the calculator. 10,000 times 1 plus parentheses 0.065 times 0.5, enter. So we borrowed $10,000 for 6 months and we paid back 10,300, yeah, $325. There you go. So this means there is interest of $325. Okay. You may have a question of, could we have used I equals PRT to figure out the same thing? And the answer is yes. All we have to do, it wants to know how much of a check was written to pay off this loan. So if you know the interest, take that interest, put it on top of the original amount borrowed, and that'll give us the same answer of $10,325. But let's try it out. So I would equal the principal amount times the rate, 0.065, times the years, 0.5. Calculate that. 10,000 times 0.065 times 0.5. Guess what we're going to get? 325. This is the interest. And if you add this to the $10,000 loan we borrowed, you would get $10,325. So, however you want to think about it, right? Either way, we get there. Okay. All right. So, next one, number 7. If you paid $120 to a loan company for the use of $2,000 for 90 days, what annual rate of interest did they charge, assuming a 360-day year? Okay. Well, again, we are going to use our simple interest theorem. So A equals P times 1 plus RT. But this question says, what annual rate of interest? So this means we're solving for R, which means that we can actually use the equation we made for R. We're going to use R equals A minus P over PT. So we'll use the rate formula. Okay. So all we have to do now is label what we're given. We're given that we paid $120. We're assuming that's the interest we paid on the loan for the use of $2,000. So this means that we borrowed $2,000 And at the end of 90 days, we paid $120 on it. So this means what we paid back was not the $2,000. We paid back $2,120. Okay. And then the next thing given is, well, time. Time is in 90 days, but you must convert to years. And is that 1/4? .25, perfect. 0.25 years. Okay, we have all the information we need, so we can plug it into the formula above. So R equals A, which is 2,120, minus P, which is 2,000, over P, the original amount, 2,000 times time, 0.25. Now let's type that in our calculator. 2,120 minus 2,000, which is just 120, over 2,000 times 0.25. And we get 0.24, which is 24% interest. Okay, cool. So the question again is, could this have been solved? Could this rate have been solved by just the simple interest formula? Let's check it out. So if I said, so if I want to do that, let's see, I would use the R formula for simple interest. So R equals I over PT. So let's try that. So R equals I over PT. Well, here we're assuming that 120 was the interest paid. So that's 120 over the original amount borrowed, 2,000 times 0.25. So let's try this out. 120 over 2,000 times 0.25. My goodness. And you get the same thing. You get 0.24 or 24% interest. Wow. So it seems that we could use either formula depending what the question's asking. This question just wanted an annual rate of interest, so the simple interest formula would have worked. So this one was simple interest. And this one was the simple interest theorem. And this was simple interest. Okay, so we see that either one works. All right. So could make your life easier by just using simple interest. But of course, it depends on the problem. Okay. Next one. 8. Treasury bills are one of the instruments that the U.S. Treasury Department uses to finance the public debt. Like they're going to do now. They're going to send us all Trump bucks. Woo! How will you spend your Trump bucks? Of course, if you're getting Trump bucks. Okay. So, what annual interest rate is earned by a 33-day T-bill with a maturity value of $1,000 that sells for $996.16? Okay. Well, this is kind of just like the last question. It wants to know what's the annual interest rate. So we don't have to use simple interest theorem. We can use simple interest. Of the I equals PRT. And since this one wants interest rate, we're just going to solve it for R, which means we already did that before. We know that R equals I over PT. Okay. Well, with that being said, let's label what we have. And let's see, first thing is the original amount. This T-bill was originally, let's see, it has a maturity value of $1,000, but it sells for $996.16. So this means that we will buy a $996.16 treasury bill, and then it will mature to $1,000, which means that to find I, you take 1,000 and subtract it from 996.16. What's that? $3.84. Yep. $3.84. And the only last part we have to do is time. T says $33 day, 33-day T-bill. So you put 33 days over 360 days, which means that 33 over 360, ugly, ugly decimal numbers. So what's the fraction? 11 over 120. That's where we're going to keep it as. 11 over 120 years. Okay, which means we have P, we have I, we have T. Let's go back and plug it in. This gives me $3.84 over 996.16 times 11 over 120. And let's see what our interest rate is. 3.84 over 996.16 times 11 over 120. And we said decimals to what? 3 decimal places for rate. Okay. So to 3 decimal places, it's 0.042. 1, 2, 3. Which means we get a 1, 2, 4.2% annual interest rate. There it is. And that would be the same as, well, solving for using, where is it? Using this formula that we did in 7. A minus P over PT. So there you go. All right. 9. What is the purchase price of a 50-day T-bill with a maturity value of $17.98 that earns an annual interest rate of 2.587%? Assume a 360-day year. Okay, what is the purchase price? So we're looking for the beginning amount. So this means that we will use simple interest theorem. So A equals P times 1 plus RT. And since we're looking for the purchase price, this means that we're looking for P. Which means that if we scroll it up, we already had an equation for P. It's P equals A over 1 plus RT. So that's what we're going to use. So for this one, we get P equals A over 1 plus RT. Now let's label everything we're given. So first thing up is time, 50-day T-bill. So T is 50 days, must convert to year. So 50 over 360, I'm assuming that's a nasty decimal number as well. So keep it as the fraction. Five over 36 years. Okay, and then we're given the final amount, which is stated as the maturity value. The maturity value is $17.98. All right, give the computer a little chance to catch up. Any day now. Okay, caught up. And then the rate given. The rate given is 2.587%, which gives me 0.02588712. Okay, plug them in to the above. We get 1798, 1738, but 98, okay? Over 1 plus 0.02587 times, so rate times time, 5 over 36. Okay, type that in. 1798, 1 plus 0.02587 times 5/36. Enter. And the purchase price is $17.91 and 56 cents. All right, there it is. That's the purchase price. Okay, cool. Number 10, last one. To complete the sale of a house, the seller accepts a 180-day note for $10,000 at 7% simple interest. This means that on this note, both interest and principal are repaid at the end of 180 days. Wishing to use the money sooner for the purchase of another house, the seller sells the note to a third party for $10,124 after 60 days. What annual interest rate will the third party receive for the investment? Okay, perfect. So this is actually pretty crazy. If you ever looked into house notes, like the business of just like buying and selling house notes, it's pretty insane. Like, and I don't think you even need to have money because you will sell the note right away to somebody else, but you earn money by getting interest from this note. So let's say I took out a loan, just like this problem says. I took out a loan for $10,000 and I say, what did they say? What are you going to do with it? It's like, oh, I'm going to buy a house note for $10,000. That's only 180. It's only lasts for 180 days. And within those 180 days, after 60 days, I gain interest on it. And after I gain interest, I take that note and sell it to a third party, which means I now have made interest and my $10,000 back, which means I can pay the bank back their $10,000 and I keep the interest. And you can keep this going for as long as you want. But I think certain states have certain restrictions, but it's crazy. Look it up. So, all right. So the first thing we want to know is, before continuing, is that how much interest did the seller get? So like I said, I'm the seller. I bought the $10,000 note, but I'm going to sell it early. But I still want to know how much interest they made off of it in that amount of time. So that's where we're going to start first. We're going to say, we'll call it seller interest. Seller interest earned, which means that we are going to use simple interest theorem. So A equals P times 1 plus RT. Okay, so let's label what we're given. We know that the seller bought the note for 10 grand. And then we know that the rate on this note was 7%. So 0.07. We know the time on this note is 180 days. Got to convert to years. So thank goodness that's half. 0.5 years. Okay. Now let's plug it into the formula above. I'll write it below. A equals 10,000 times 1 plus 0.07 times 0.5. Let's see what we get. So this is the interest the seller would earn if the seller let this note sit for 180 days. So 10,000 times 1 plus 0.07 times 0.5, enter. So $10,350. Okay, so this is the final amount. This is the future value of that note, right? Future value of note, of house note. Future value of house note. Okay. All right. So this is what the seller would make if they waited out the 180 days. But now, they want to use their money sooner. So I don't want to wait for the 180 days. I want to use this money now. So I found a third party. And this third party is willing to buy the note for $10,124 after 60 days. What interest rate will the third party receive for that investment? So now it kind of works like this. So I have the note. I borrowed the note, so I own the bank. But now the third party bought the note from me, so now the third party owes me. But I still kind of owe the bank. But since they owe me, all that interest is going to me. I have my $10,000 back, so I can pay the bank off. So basically, the third party owes me that note, the rest of the note. So I'm getting interest on that. So it sounds crazy, right? I wouldn't even want to be in that business. Sounds like I know what I'm talking about, but I barely even know what I'm talking about. I just know the gist of it, okay? Okay, all right. So this next part is going to be for the second part of the problem. What annual interest rate will the third party receive? So we're going to call this third party interest rate. And since it's looking just for an interest rate, guess what? We can use simple interest. I equals PRT, where if we're solving for rate, this means that R equals I over PT. So let's label everything we know. All right, so now this third party has bought the note for $10,124, right? Let me move my face. There we go. This third party has now bought the note. The beginning purchase price of their note was $10,124, which means that to find I, well, the final amount of this interest note should be the $10,350. So I is going to be 10,350 minus 10 124. So 10,350 minus 10 124. So 226 is the difference. Okay. And then time, well, the third party bought this note after 60 days. So this note was originally good for 180 days. But now 60 days have passed. So there's only 120 days left on the note. Oops, you're not seeing any of that. Sorry. So there's only 120 days left on the note, which means you still have to convert to years. Nice decimal or not? 120 over 360. Not a nice decimal. So we're going to keep this as 1/3 years. Okay, so we have everything we need. IPT, plug them in to the above, and I'll write it above. So I is 226 over P, 124 times the rate of 1/3. I mean, not rate, times time, 1/3 years. We're looking for rate. And I do fraction, 226 over 124 times 1/3. And we're doing decimals to rates to 3 decimal places, so 0.06 round up 7. So this third party is going to get a 6.7 interest rate. So this is the interest rate. So this is the interest rate I'm charging them to collect on the note they bought from me. I'm the bank now. Ha! Crazy, I know. Okay, that's how we do it. That is 3.1. That is simple interest theorem and simple interest. So, depending on what the question's asking, you know whether to use simple interest theorem or you know whether to use simple interest. Just depends. Okay. And that is it, guys. So, hopefully this was fun. More applicational, right? All right. So, this means that I will stop recording.